Okay, name and major.
My name is Andrew Bernarski, and I'm the robotics and automation major. I'm Zachary Conley, I'm the robotics and automation major.
Okay, what you got here?
Pretty much what we're doing is we're taking our PLC and hooking it up to a robot. And then we have up here a human-machine interface, our HMI screen, to be able to easily explain what's going on. And our project's goal was to be able to put a resistor into our tester and be able to sort it. We also wanted to be able to pick out a bad resistor as well. So we have right here is I put in my resistor, and then automatically, if we look at our screen, we're going to see our resistance right there. We see it in our resistance level, and then if we switch it.
Now that told us it was going to go to bin 1, so we already knew where it was going to execute before the robot even did anything.
So there we have another one, we have our 100 resistor in. So if we click start, we can watch the robot sort it to bin number 2.
Okay, so this says bin number 2.
This is our bin number 2.
And there you go, resistor sort. Huh.
And if we notice our fancy little box over here, we have a couple burnout resistors as our error.
Yeah.
And we want to be able to put this in here so we know while we're sorting that this is a bad resistor. So we're going to click start.
We can see how our error messages come from telling us it's a bad error resistor.
Now, how does it tell it's bad? Because
It'll show it as a much higher resistance.
much higher resistance.
And if you notice right now, there's an error on right now because the resistance of the air is definitely way too high for us to sort it out.
Right.
And if you would click start, it would try to pick up the resistor right there and put it there because there is technically resistance there.
Right, just a high limit error.
Yeah,
Okay.
basically it's telling us we have a limit of the resistors where we are, and we want to measure. So basically, if it's out of it, it's a bad resistor. We don't use it.
And this is just a simple example of inputs and outputs and interfacing a PLC to a robot. In an industrial setting, you would be using something that required much heavier voltage, a much more powerful robot, and it can really do a lot of things if you really put your time in and you work it out.
Now, for your resistance, you're using the analog input on the PLC. Is that how that works?
We are using, to get our resistance, using our power source to put 10 volts into the PLC. And then the PLC is doing a mathematical operation here, and that's what's giving us our answers. Okay. And we're going off our resistance to be able to decide what bin it goes in. So we have 5 different resistors that we want to test out. We have our 100, we have our 10, 100, 1,000, 3,000, and 10,000.
Yeah. Now, what PLC are you using? The Allen Bradley here?
RS Logic 5000, Allen Bradley.
Okay. And your screen here is made by, is that the HMI?
That is HMI.
Is that Wonderware? Or is that
Factory talk.
okay.
Yep.
And how did you make that screen then? To the Factory Talk software?
Yep. There's different options. Our test on and our start are both momentary switches, and you can program. You can have different ones that'll stay on, or different different concepts and things. But
So this is just a visualization of your ladder logic, basically?
yes. Yeah. All right. A little simpler. Yep.
Yeah. Okay. Cool. All right. Thank you, guys. Good job.